Alright, yeah, I'm going to do a little more machining today. These are the rods for those plow cylinders. Last Saturday I bored and threaded the holes for the clevis end. And now I'm going to get ready to do everything I need to do down here for the piston end. First things first, I'm going to get set up in the mill and come in here and face all the ends off where I'm going to turn it down, because I cut these things long. Not a lot. You can't be exact cutting in a saw, so you can leave them a little long, and then when the time comes, you mill them off or turn them off in the lathe or whatever to get them to all be the exact same length. Well, I got all my holes bored the way they were, and then this side needs to be true so that I can center point it to run a tailstock support when I'm out here turning, so it doesn't start to weeble wobble on me. You can get away with it without doing it when you're drilling, because when you center it and then you run your drill in, your drill becomes your center and it's not going to start walking all over the place. But if you got something, because it'll only go in the chuck about yay far, and then when you're out here with your tool and you start pushing on it and digging in, it'll start making it do all sorts of goofy shit, because you're got, what, 6-7 inches of leverage outside of the chuck. And the original rods measure 11.5 tip to tip, so I cut these about 11 5/8 roughly, so I got to mill a little bit off. So I'm going to go ahead and get set up and go from there. Alright, so came in, put a backstop in, zeroed off the backstop, zeroed off the back of the vise, which actually for what I'm going to do here isn't important, but I'm going to do a second operation on it, which is important to have the zero off the backstop. And to do that, use a wiggler. You stick that in there and put it off center like that, and when you butt up against your work surface, it starts running true, and that's when you know to run zero, or know you're on zero. Then you move over 0.1 and then zero again, and then you're on center of that tool. So did that, zeroed off of here, and then I'm using a 3/4 end mill, so I backed up 375 and zeroed again. So now that would put the edge of my tool, or the edge of my mill, at zero here, so that when I move over to 11.5 on there, I'm actually at 11.5 at the edge of the mill, not in the center. And it's about that rod's about 3 5/8, or not, sorry, about 11 5/8. And if you butt the mill up here, which would be 11 675, and obviously it's not exactly 11 5/8 because it's just saw cut, but when you butt the mill up against it, it comes out to 11 630 something. So pretty close. And obviously you sneak up on it and measure it on the first one, and then you know where your numbers are for the second one. So anyway, find a place to stick you and go from there. See, that's where your saw cut's going to be an issue, or would be an issue if you were trying to do this, or just trying to work off that surface. If you heard it, I'm touching steel here, and when you get to the other side, it's touching nothing, so that saw cut's at a slight angle. You can't tell by looking at it, but if you run it in something a little more precision than a bandsaw, you can tell. just gonna double check where we're at. Because you can always take more off. It's really hard to put more back on. Ideally, you'd have a nice set of calipers to do this with, but yeah, still got to shave off about a 1/16. We got a set of calipers big enough, but they're 4-footers, and that's a little excessive. And last pass. Come on. There's a little bit of slop in this table, and when you lock it in, it walks a little bit. But this mill's a 1966, so she's got a right to be a little sloppy. And that should be 11.5 on the nose. Perfect. And because I got a backstop in it, all you got to do is slap your next rod in and go the same way. So just got to do that 4 more times. Alright, so next thing I got to do is I'm milling wrench flats on the end of the rod so that you got a way to get a hold of it in case those eyelets get stuck, because the original rods didn't have anything. Your only option was to get on with a pipe wrench, which messes the end of the rod all up. You don't have a lot of room to work. That's a 3/4, not quite 3/4 flat for a wrench, and it just barely, a little bit of this radius sneaks inside the rod wiper. I just halfway stuck a cylinder back together. It just barely sneaks inside the rod wiper. But for what it's doing, it'll be alright. Because the other thing we're going to do, as long as there's enough room, is we're also, before, they'd never had anything to jam these in. They just ran them in, and wherever they needed to be, they just left them there. So there was nothing to keep the rod from turning and unscrewing this, which was kind of stupid. So if there's enough room, I've got jam nuts, and I'm actually going to, when you get everything adjusted, have a nut on there so you can jam nut it so nothing can turn and come apart. So I got one done already. And what I did, switched to a 1/2-inch end mill. And this is where it's nice to have Dad around, because I started doing it the hard way, and then he showed me the easy way, which was more logical. I should have thought of it to begin with. But come over to 0, or come over to center, 0, and then your offset either way is going to be the same. And when you do some math, you take 1 5/16 inches, which is the wrench I'm setting it up for, which is 1.3125, divide that by 2, and you get, can't remember the number, 6 something, and you add half the diameter of your end mill. So a 1/2-inch end mill, half of that's gonna be 1/4, so you add 1/4, and you get 90625 for your offset, and that puts it right on size, and the wrench fits kind of tight. So I actually ran to 9055 just to give a little extra room, and that makes the wrench fit real nice. So yep, that's nice. climb milling. Well, this is called climb milling because as you're going in, it's trying to climb the part. It's really tricky on an older mill because there's enough slop in the screw, it'll try to bite and it'll draw the table over, which is what it just did right there. You just got to be aware of it, otherwise it'll break your tool. You gotta remember your two S's when you're machining. Speed, or not two S's, S and F, speeds and feeds. I messed that up. So yeah, feed comes into effect when you're doing that and you got a little bit of side slop in the table. But anyway, that's how that's done. Well, there they are. Clevis end's done. So next step is going to be, now that I got them all milled to the same length, got that all done, last thing got to do is turn this down and thread it, which is going to be interesting because we don't have a 7/8 die, so Dad's going to teach me how to single point thread on the lathe, and I've never done that before, so it's going to be interesting. We'll see what happens. But anyway, just wanted to clarify real quick because I stumbled when I said it. Speeds and feeds, S and F. So that's the speed of the tool that you're running, in which case that was using an end mill. That whole machine is called a mill, and the specific tool I was using is called an end mill. So speed is the speed of the tool that you're using, and feed is the feed rate which you're pushing your material, your work material into the tool you're using. And it's one of them deals, you can pull out a machinist handbook and somebody's already done the math and they say, okay, for this material using this kind of tool, you need to have this spindle speed and you need to have this feed rate and yada yada yada. But after a while, it's one of them deals where you do it and you just get used to running it by feel and sound, and you can tell when you're pushing too hard or when you're not pushing hard enough, or when you got too much, when you're running too fast or running too slow. And in general, the bigger the tool you got, the slower you want to run. The smaller the tool you got, the faster you want to run. And feed rate really depends on the material you're working on. The softer the material, the harder you can push it. The harder the material, the slower you got to push it. So that's my little uninformed machinist tip for you. So anyway, we'll cut her off here for tonight, and tomorrow we're going to start running the lathe again. Alright, so time to get these rods turned down for the piston end. And first thing I got to do is get as much of the run out as I can out of it. So to do that, there's 4 of these jack screws in the chuck that'll move that chuck around on a back plate, and you use that to get the run out. So you find your high spot right there, and looks like we got about 2.5 thou-ish, somewhere in there, not a lot. So if that's our high spot, it's going to be, and all these are numbered, so this is number 2. And then, so you got 2, you got 1, 4, obviously in a circle. So then you do that, and then you come here. I'm trying to do this where you can see. This is kind of a, I think you'll sit there. Oh, don't fall. And you turn this screw, and you'll see your dial move a little bit. Then you come around, and it looks like 3 is about our low spot. So you back. I had to turn 1 in to get it to move the needle that way. Well, now I need to move the needle this way, so you back 3 off a little bit. I got a low spot on 4, so back 4 off just a hair. A little more. And kind of got a low spot right about there. Oop. Now I'm walking around a little bit. See what this gets me. Come in a little bit there. That is not bad. We're not building a rocket ship. That little bit, you'd probably never even notice it. Alright, so now that we got it indicated, just take your base off. So then I'm going to come in, prick it with a center drill, and then you put in your tail support, which is this guy here, and we can start turning. So I'm going to finish getting this set up and we'll catch you when I'm done. Alright, center drilled, got my tail support in, got a stop set up for the carriage so that I come to the same spot every time. So basically what you'd end up doing is you're going to walk all the way down to your diameter, and then in your last pass to true up the shoulder, you walk all the way in, stay in, and then crank your y-axis out, because this is X, Y, and then this doesn't really have a Z. So you, on your last pass to get your final diameter, walk all the way in, up against your shoulder, and then walk out, and that'll square your shoulder up. So yeah, should be ready to rock and roll. Got to turn this down to 872, I think is what it measures on the old rods. So a little bit of material to hog out of there. Well, there's the first one done. Now that I got that all set up and everything's where it needs to be, I'm going to go ahead and get all the other 4 turned down so that I don't mess my settings up, and then I'll go back, reset up again, and get set up to cut that O-ring groove in there. So a little bit more to go. Alright, so the next step is to cut the O-ring groove, and I already did this one so that I could just I already knew what numbers I needed. I could just stick it in the mill or stick it in the lathe and do it real quick to make the video shorter. So I'm already set up, so we'll get that done here. Trying to not stick you in the same spot here every time. I could probably run a little faster, but I've had bad experience with these parting tools, and I just prefer to run a little slower and not break it. Stop right there and check it real quick. Because like I said before, it's a whole lot easier to take more off than it is to put more on. Oh, just a hair more. Should be damn near. That should do it. That'll do it. Next. And there you have it. 5 grooves cut. 5 studs turned down. All we gotta do is thread them in the morning, and that's the tool we're gonna use. So we will catch you in the morning. Alright, well, getting or cutting threads on these rods. Dad showed me on the first one, and then I did these 3 just to get used to it before I made the video, because I wanted to be concerned about cutting threads, not making video, because this is the first time I've ever done this. So I'm all set up. I came in here, scribed the line with the tool where I need my threads to end. And this is a 60-degree thread cutting tool. You come in here and you get your gearbox set up for the thread pitch you want. In this case, it's 7/8 14, so 14 pitch thread. You're going to end up on this this gear. And then you got 3 options with your transmission, left, center, right. And to get the 14, you need to be on the middle, so that's set up on the middle. And then this is your threading drive screw, and this is your thread gauge. And basically what you do, you have your indexing table set up at a 60-degree angle right here, and your y-axis set at 0 when you touch off on the part, and this always goes back to 0 when you actually index the tool in on your indexing table. And what you actually do is you cut the leading edge of the thread. You don't just drive in and cut the whole thread in one shot. You're cutting off of this side of the tool, and you're only cutting the leading edge of the thread. Otherwise it'll rip the whole thread off if you try to bury the tool and cut the whole thread in one shot. So what you do is this, when you're not just normally running a power feed on the table, it runs off of this jack shaft. Well, that's what this lever does, is disengage or engage and disengage that clutch, and that will engage a gearbox in your carriage and work the turn wheel. What this does when you need to thread is you loosen it up and swing it down and engage it on the screw, and then this clutch engages this feed, which has nothing to do with the carriage. And basically what happens is this is bit into that screw, and when you stop this, the screw pushes the carriage. And the way this is all geared, if you, well, right here, to use chasing dial, odd threads on number lines, even threads on any line, and you got a line here, 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 and then your numbers. And it's hard to see, but there's a little arrow right there. And basically, as a line comes around and lines up with that arrow, you drop it into gear, and no matter where it is, that tool will come in and engage the thread exactly the same time, or in exactly the same spot every time, and you just keep making passes until you get your thread to the size you need. And there's actual measuring tools to figure out what size you need, but Dad does this so little often that he doesn't really have any. So basically all we've been doing for what we're doing is start trying to thread the nut, and when the nut thread's on, you stop. So yeah, actually the furnace would kick on right now, but that's basically the gist of how this works, and you'll see it in practice here in a minute. So get you set up and get rolling. It doesn't take as long as you'd think, I tell you what. Alright, you kind of got to concentrate what you're doing here, so I'm not going to talk a whole lot while I'm doing it, but just pay attention, because everything kind of happens really fast. Because it don't take a whole lot of material out to make a thread. On your last pass, before you check to see how your threads are, you just go back in and reset your Y at 0, leave your index where it is, and just run through it again with the tool in the same spot, just to clean out any material you might have missed. It doesn't make a lot, but it's pulling shit. Got that one in one shot. And there you have it. Cutting threads on a lathe. Now, you come through and you can use the same tool to chamfer the end off, because it tore the end a little bit where it entered and it kind of rolled the metal. So you just come in with like halfway back up the tool, and you just chamfer the edge back a little bit, get rid of that burr. But there you go. All the threads are cut. Well, there you have it, all back together. And this is from if you remember when I was talking about cutting these wrench flats on, they just barely sneak inside the rod wiper. There you can, it's not nearly as bad as what I thought it was. Now that the cylinder's all together, it just barely starts to roll over the cut, so it's not actually letting go of the rod. So we're good, but hard part's done. And then this morning while I was waiting for Dad, I cut the accumulator apart, because we either needed to know how big it was or what its capacity was so that we could size a new one, or we were going to cut this apart, put new seals in it, and weld it back together. Anyway, we were either going to cut it apart, reseal it, weld it back together, reuse it, or the better, hopefully better option is we just find a newer accumulator that's actually serviceable, and you could take it apart and reseal it or whatever you got to do, and just shit can this one. Because I had a little accident, not that it matters because there's still another one on there, but I had a hell of a time getting the piston out because it was stuck all the way down here, and obviously there's no way to get a hold of it, so I put some air to it, and when I did it went, and I put a doink in it, in the piston, so yeah. But like I say, ideally we're just not going to use that accumulator. We're going to get a brand new one that you could actually take apart and work on. So, but once that's done, or once we get that, I got to get one cover board and seals for the coulters, but I got to get one apart first. And other than that, should have pretty much everything I need to just go through and finish the plow. Now I'm probably actually going to bring it down tomorrow and knock the bottom off and move the tail wheel up and get the hydraulic system tore apart on it. And this time I'm not going to make it blow oil all over. So, and because there was so much lathe work in this video, I'm going to say this again to all the younger guys that might watch my channel that might be in high school or whatever. If you think you might want to screw around with machining, think about trade school after high school or school of work, or if your school has a metal shop class, look into it hard, because that's just, most of the guys that are doing that now are my dad's age and getting close to retirement, and there's no younger guys going into it, and once this country loses that skill, it's gone forever. Being a CNC lathe operator is not a machinist. You load the part in the clamp, you hit the go button, it runs through its cycle, and then it spits out a done part. That's not, I'm not putting that job down because it's boring as hell, and anybody that could sit through it, I had more power to them, but that's not a machinist, you're an operator. So, we need more skilled workers is what we need. Everybody thinks this country's doing good, but once we lose our skilled labor force that's getting close to retirement, we're screwed. So, that's my preaching moment for this video. So, anyway, I'm assuming this is getting long enough because I've done it over 3 days and I don't know how much video I've actually got going. So, I guess that does it for this one. We'll catch y'all probably tomorrow on that plow.